In your math class, right, the basic math of all math is that if you have x over x, what happened to it? It cancels out, right? Now, why is that? Because they are the same, so it actually simplify into 1. Or if you have x times 1 over x, and what would that do? This x still cancel each other out, which is simplifying equal to 1. So we are going to do the same thing to our measurement and unit. So here we have household ammonia, okay, NH3 is a solution of ammonia in water. So we add pure ammonia in water. It's used as a general purpose cleaner for many surfaces because of its antimicrobial agent. That means it's gonna kill bacteria, okay? So antimicrobial or micros mean microorganism or okay, like bacteria. Anti mean is against bacteria. So that's what the purpose of ammonia is. Now, if we have 3.5 grams of ammonia is used to make a cleaning solution, how many molecules of ammonia are in the solution? Okay, and the molar mass of ammonia is 1.3 moles of ammonia equal to 17.03 grams of ammonia. Well, we can tell that this is our given grams, right? And what are we looking for? Molecules of ammonia. So this is our given. So our given is 3.5 grams of ammonia, NH3. And we are looking for, in this case, the unknown is molecules of ammonia. Okay, so let's go back to our stoichiometry flowchart. Where do we always start again? From our given. And where do we always end? At the unknown. So in this case, our given is 3.5. Okay, let's zoom out a little bit. So our given is 3.5 grams, which is right here, grams of ammonia. And where do we end? We are end at molecule, which is right here. So we're going down. That's our first conversion factor. Okay. Then what's next? We need to go across. That is our second conversion factor. So let's create our conversion factor. So what we have here is this. We have starting from a given, which is, well, before we do that, let's look at the format. We start with the unknown. What are we looking for? Question mark, molecules, remember the singular form of NH3, okay, equal to, starting with our given, in this case is 3.5 gram of NH3, which is right here, okay? Now, times the next conversion factor, which is that going down, we copy exactly 1 moles of A, which we know is NH3, equal to the number of grams of NH3. And we can actually plug that in right now because we know that number is your molar mass, which is 17.03. So we can put that 17.03 gram. Then we're done with that conversion factor. Let's go on to the next one. Times the next conversion factor, which is 1 moles of A, in this case NH3, equal to 6.02 times 10 to 23rd, not represented particle. We know exactly what it is molecules. So it's molecules of NH3. And we are done with that conversion factor. Now let's apply the concept of conversion factor to cancel our unit. Well, again, we always start from our given, as always. That's what we're starting with. So we have 3.5 grams of ammonia. Okay, and we want to cancel out grams of ammonia so we can get to molecules eventually. So if that's the case, let's look at the next conversion that multiply to. If this is grams of ammonia, the grams of ammonia must be on the bottom. So grams over here and moles over here. In this case, of course, that is 17.03 grams of ammonia. Where do I get that 17.03 again? It's from the molar mass given to us right there. And then on the top part, which is the leftover, which is 1 mole of NH3. There you go. We are done with that conversion factor. Let's move on to the next one, which is that one. Now, before that, let's cancel grams of ammonia. We have moles of ammonia left. So if this is moles of ammonia, let's look at the next conversion factor. Which of them is going to be on the bottom? Of course, it's going to be moles of ammonia. We need to cancel that out. So we have 1 mole of NH3. That's going to be on the bottom. The other part must be on top. This part must be on top. 6.02 times 10 to the 23rd molecules of ammonia. And look what happened, moles of ammonia cancel out. Just like we did right here, X and X cancel each other out, right? So, since I'm running out of space, I'm gonna continue right here. And that is gonna be, again, multiply every number on top, ignore the 1. Then divide every number on the bottom, and ignore the 1. So on top, we have 3.5 times 1, which we can ignore, times 6.02 times 10 to the 23rd molecules of ammonia, NH3, and divided by everything on the bottom. In this case, it's just 17.03 because we ignore the 1. And that is our answer right there. It's not 9. And if we plug this in our calculator, let's plug this in our calculator. We have 3.5 times 6.02. Again, this is represented by exponent or double E. So E, and that's 23. And then divide everything on the bottom, which is, in this case, we don't have one number, 17.03. And give us our answer of 1.24 times 10 to the 23rd molecules of NH3. So isn't that amazing? By just adding 3.5 grams of ammonia, you actually adding that many molecules. And how many is that molecule? That is like, if you have that number in term penny, you'd be the richest person in the world. And that's how small a molecule is. Okay? So that's the power of chemistry. Isn't that nice? And that is how you apply this into that. You want to try another problem? Okay, let's try another problem. Whew. Now, here we have propane. It's a popular choice for barbecue. Yes, I love barbecue all the time. And it is popular for portable stoves because of propane low boiling point, and it is very combustible. What does that mean? It is readily react with oxygen to produce carbon dioxide and water and a lot of heat. If 450 grams, that's not a lot, okay? That's about 1 pound of propane, is added to an empty propane tank, then the tank has how many moles of propane at standard pressure and temperature? The molar mass, in this case, is supposed to be propane, I apologize, which is C3H8, is 1 mole of propane, C3H8, equal to 44.01 gram of C3H8. So how do we do this? First of all, we need to identify our given, which is right here. So your given is, in this case, 450 gram. We can abbreviate that to C3H8. And what are we looking for? We're looking for moles of propane. So a question mark, which is represented by U, unknown, question mark, mole of C3H8. Okay, sorry about the ugly writing. So let's go back to our flowchart. Again, we start with the given measurement, which is grams, so that's where we're going to start. And where do we end? At the unknown, which is mole. Oh, look at that. It's only one conversion factor, starting from gram to mole. So that's pretty easy, isn't it? In this case, let's set up a flowchart, starting with identifying what we are looking for, which is mole of C3H8, okay? And we are looking for what? We are starting, again, with our given measurement right there, okay, right there, which in this case is 450 grams of C3H8 time the conversion factor, which is that one right there, isn't it? Going down, that's the only one. So time that conversion factor, which is equal to 1 mole of A, we know it's going to be C3H8 equal to number of grams of C3H8, but we know that that number is the molar mass, and it is given to us. It's right there. Molar mass, 1 moles of C3H8 equal to 44.01 gram of C3H8. So that number is 44.01. And we are done. How do we rewrite that? It look in a form like this so we can cancel out the unit and the chemical. So here we have 450 grams starting from a given C3H8 time that conversion factor, And the tricky part, what go on the bottom? All you have to do is, what do you want to cancel out? So what is right there? What's the previous unit? If this is gram, so the gram must be on the bottom. So exactly 44.01 grams of C3H8. If this size of the conversion factor on the bottom, the other side must be on top. So the 1 mole of C3H8 must be on top. That cancel out. And then what do we have? We're done. That's it. So now we just multiply everything on top, divide everything on the bottom. Remember to ignore the 1, so we have 450, alright, time 1. Well, we cannot ignore this one, but we can ignore the number, but we cannot ignore the unit because the unit is still there. So we can say that that's actually time mole of C3H8. But no one write the time to the unit. We just need to realize that it is being multiplied, just like the prefix before, right? And then we divide everything on the bottom, which is, in this case, 44.01. And that's it. You can plug the rest in the calculator.